All right, so this is part 2 of the video for review for parts 2.2 through 2.4. We're going to do these last 2 problems on page 1, and then we're also going to do page 2. So let's see. So on number 16, we need to first, part A, find the zeros and their multiplicities. So for x squared, that would just be 0. And because it's squared, it has multiplicity 2. For x minus 2, our 0 would be 2. And because it has an exponent of 3, the multiplicity is 3. And for our last one, our 0 is negative 3, and its multiplicity is also 2, because it's squared. So there's our zeros, our multiplicities. Part B is to decide whether they touch or cross at each one of these zeros, which remember are our x-intercepts on the graph. The even multiplicity touches, right? And the odd multiplicity crosses. So this is going to touch at 0 and negative 3 because both of those have an even multiplicity, and it's going to cross at 2 because that has an odd multiplicity. All right, part C, find the y-intercept. Remember, we find the y-intercept by plugging 0 in everywhere there's an x. So 0 squared times 0 minus 2 cubed times 0 plus 3 squared. Since there's a 0 out front here, it's just all going to go to 0. So that's the y-intercept. Part D, we need to sketch the graph. So first thing we want to do, just put all of these intercepts on here. So I know there's one at 0, an x-intercept at 0, one at 2, and one at negative 3. I know the y-intercept is also at 0, so that's already on there. We got to then look at the degree and end behavior. So the degree, remember, is how many times x is being multiplied together. So in this case, 2 plus 3 plus 2, which is 7. And if it has an odd degree, the ends are going to behave the same as for x cubed. So I know this one will be down and this one will be up. Those would switch if it's negative right out here. If there was a negative in front, then I would actually switch those and this one would be up and this one would be down. Remember, if it's an even degree, they both go the same direction. So either both ends up or down depending on positive or negative out front. All right, so this is going to come up and approach each one of these zeros. It's going to either touch it or cross at each one. So remember, I've already looked up here at which ones it's going to touch at, which one it's going to cross at. So negative 3 is the first one I'm coming up to, and that one's going to touch. So I know it's going to come up here and touch that one and turn back around. I know it's got to go back up to either touch or cross at 0. And again, it's going to touch. So it touches and then it has to go down again. And then it's going to come back up again and it's going to cross it too and end up upward. So this would be the sketch of the graph. On number 15, it's a little bit different just because it's in standard form. So we're still going to go through the same process, but before we begin, we're going to have to change forms. We're going to have to get this in factored form. So in order to factor this, I'm looking for common factors. So 2, 6, and 8 have a common factor of 2. X to the 5th, x to the 4th, and x to the 3rd has a common factor of x cubed. So I'm going to pull 2x cubed out front, which is going to leave me with x squared minus 3x minus 4. So the 2x cubed out front we can kind of ignore, but we need to still have it there. We're going to x factor this stuff that's still in the parentheses. So a is 1 and c is negative 4. 1 times negative 4 is negative 4. And then our b is negative 3. So I'm looking for two things that multiply to negative 4 and sum to negative 3, which would just be negative 4 and 1. So I can rewrite this as x minus 4 times x plus 1. Then I would need to divide each of these by a, but a is 1, so it's not going to change anything. All right, so now it's in the same form as these others, so now I can just go ahead and go through my steps. So for part A, I need to look at the zeros and their multiplicities. So the first one, because the 2x out front, would be 0 with multiplicity 3. So the exponent is 3. And then I also have positive 4 and negative 1. Those ones are both multiplicity 1. Part B, does it touch or cross at these? Since all of the multiplicities are odd, we have multiplicity 1, multiplicity 1, multiplicity 3. it's going to cross at all three. So cross at 0, at 4, and at -1. Okay, part C, we need to find the y-intercept. And in order to find the y-intercept, I plug 0 in for x. I can do it to the original problem right here, or I can do it to my factored form. You'll get the same answer either way. Because every term has an x here, all of them are going to go to 0. So it's going to have a y-intercept at 0. Okay, finally, let's sketch the graph quickly. So my zeros are at, well, 0, 4, and -1. My y-intercept is at 0, so it's the same point as that one. The degree is 5, right? In this form, I can just look at the highest exponent. I would have to add them up here, but the degree is 5, which means it's going to behave like, the ends are going to behave the same as x cubed, and it's positive out front, so it's not been flipped, so left, down, right, up. And I know it's crossing at each intercept, so it's going to go up, cross, come back down, cross, and then go back up and cross. So that would be the graph. Okay, let's go ahead and look at page 2. So number 17, we have long division. So I'm going to write my long division box here. I'm not going to have a ton of room to work here, so I'm going to probably just have to write over the stuff below. Hopefully that won't be too confusing. So x to the third plus 6x squared. Remember to check each one of these terms to make sure they go down in order. So 3 to x would be x to the first, and then the one without a variable. Remember, I'm just looking at the first two terms. So what would I need to multiply x by to get x cubed? And that would be x squared. So we put x squared above the other x squareds and then multiply it back by these others. So x squared times x is x cubed. X squared times -4 is -4x squared. Okay, remember we need to subtract this one from the one above, so that would become a -x to the third and a positive 4x squared. So that goes to 0. So I have 10x squared, and I'm going to bring down my next term of -50x. Then I'm looking at x again, and I'm comparing it to 10x squared. What would I have to multiply x by to get 10x squared? And that would be 10x. So 10x times x is 10x squared, and 10x times -4 is -40x. I'm subtracting both of these. We'll change their signs. That one goes to 0. That first one should always go to 0. -10x, and then bring down your 38. So again, I'm just looking at the first term here and here. What do I need to multiply x by to get -10x? And that would be -10. Multiply it back to the divisor, so -10x. -10 times -4 is +40. Change those signs because we're subtracting them both off. 38 minus 40 is -2. So that's my remainder. I always put the remainder over the divisor. Okay, so there's the results. Okay, for the next one, we have 10x minus 7 into 90x squared minus 33x minus 12. We're okay on our exponents here. They go down in order. If they did not go down in order, we would have to put a 0 in place of anyone that was missing. Looking just at the first term here and here, I would need to multiply 10x times 9x in order to get 90x squared. So go ahead and multiply that back over here. 90x squared, 9x times 7 would be -63x. We're subtracting both terms off, so change their signs. That one goes to 0. So it would be 30x minus 12, just bringing that one down. 10x times 3 is 30x, so we'll multiply by 3. So 3 times 10x is 30x. 3 times -7 would be -21. Change our signs. That one goes to 0. And that would be, let's see, 11 plus 8, 19, 9. All right. So our remainder is 9. So we would need to add on 9 over 10x minus 7. All right. So now, in order to go on to the next problem here, I'm just going to erase a little bit of the bottom of that one. All right, so on this next one, we want to do synthetic division instead of long division. So remember that was just another method for dividing. So we're going to make our box upside down. We're going to find the 0 for our factor, or for our divisor, which would be a positive 5. We're going to put the coefficients across the top. They should go in order from highest exponent to lowest, 3, 2, 1, and and no variable. And this one does, so we don't need to worry about putting any zeros in there. The remainder is going to be under that last number. Bring straight down the first number and then multiply by the 0. So 5 times 8 is 40. Negative 41 plus 40 is negative 1. 5 times negative 1 is negative 5. And 4 minus 5 is negative 1. 5 times negative 1 is negative 5. And 13 minus 5 is 8. So now we need to write this as a polynomial because this one had 8p to the third. I know this 8 here is going to have 8p squared. And then each one is going to go down 1 degree from there. So minus 1p minus 1, and then our remainder will be added on and put over the divisor, just like in long division. My divisor is the p minus 5. Okay, so I think we're going to actually go ahead and skip number 20. It will be on the other key, but you can look at that. All right, so on these ones, we're just simply trying to see if this goes evenly into this. So when it says, does this binomial give a factor of the polynomial, it's asking you, does this go evenly in? So again, you can use long division, you can use synthetic division, and remember you can even use the remainder theorem, which just says if I plug in the 0, the 9, for all the n's here and evaluate it, it should evaluate to 0. If it does, it's a factor. If it evaluates to anything else, it's not. But I'm going to use the synthetic division method here, and I'm going to just see if this will give me a 0. So 9 times 8 is 72. Negative 76 and 72 make negative 4. 9 times 4 is 56, I think. 9 times 4 is 36, sorry. And 34 plus 36, oh sorry, negative 36. So 34 minus 36 is negative 2. 9 times negative 2 is negative 18, so we have a remainder of 0. Because of that remainder of 0, then yes, this is a factor. It went evenly in. Okay, so do the same thing on number 22. On 23, it's giving it to us a little bit differently. It's saying, oh, here's our function, and we want to know at x equals 3, is this a factor? This is the one where maybe you want to just plug in 3 everywhere there's an x. If it evaluates to 0, it would be a factor. If it evaluates to anything else, it would not be a factor. So you can do it that way, or you can use synthetic division again, whichever one you prefer. Whoops, that should be a 3. Whichever one you prefer will work. But if you're going to use synthetic division, this already is the 0, so you wouldn't change the sign like you did in the previous one. All right, so stating the possible rational zeros for the function. All right, so remember we want to look at the factors of the leading coefficient, and we want to look at the factors of the constant. We want the factors of the constant over the factors of the leading coefficient. So I'm just going to look at all the different combinations I could have, which in this case is just 1 over 1 and 1 over 2. But we could just have the positive and negative of both of those. So there's all of the different options. Now just take each option and plug them in order to find out if any of them are 0. So you can either do it like this, like number 23, or you can do it with the synthetic division. If you get that remainder of 0, you know that one is a 0. So you can check all 4 of these: positive 1, negative 1, positive 1/2, and negative 1/2. You just need to find one that's actually a 0. So if you find one that goes in evenly, you don't have to check anymore. So you can check them again with synthetic division or using the remainder theorem like we found number 23. So I know I didn't finish 23, but go ahead and look at the key and see if you can do them. If you have any further questions, just email me.